Say there is a business problem, and the business problem is as follows. Should we open the new store or not? For this, your business has to come to you and say that they want you to be 95% confident, right? That's called as 95% confidence level. They want you to be 95% confident with the decision that you're going to take on whether you want to open a new store or not. Right? Say they have come to you and told that. So you take 95%, which is confidence level, which is also given a notation called 1 minus alpha. If you are expected to be 95% of the times correct, that means 5% of the times you might go wrong. And this 5% of the times you might go wrong is given a notation called type 1 error because 5% chance of you going wrong, or it is also called as alpha. Now you need to come up with null hypothesis and alternate hypothesis. Taking no action means not opening the store. That is null hypothesis. Null, do nothing. Alternate hypothesis says take action, do something, open the store. When would you open the store? If the probability of you going wrong if you open the store is going to be less than 5%, right? If the probability of you going wrong would be less than 5%, only then you would open the store. What does that mean? That is when you're going to accept alternate hypothesis, but statistically we say we reject null hypothesis. We talk only in terms of null hypothesis on whether we reject or we fail to reject, and that's statistical term. For business purposes, accept alternate hypothesis also would make sense. Okay. So what does this mean? You're going to open the store. This is given a slang just to understand. P low, null, go. Meaning you're going to reject null hypothesis. Null, go. Yeah. And if this p-value is going to be greater than 5%, then there is greater than 5% chance that you will go wrong if you open the store. If the chances are high that you will go wrong if you open the store, then you'll not open the store. What does that mean? You accept null hypothesis. You do not open the store. Accepting null hypothesis is also called as fail to reject null hypothesis. Right? This also means fail to reject null hypothesis, which implies do not open the store. Yeah, and this is given a slang once again for us to remember easily, and that is P high, null, fly. That means you would fail to reject null hypothesis. If you all are wondering on why I have taken 5%, right? I have taken 5% because my business has told me that I need to be 95% confident with the decision that I take. That means there's a 5% chance that I might go wrong. All right. So P low, null go, P high, null fly. If my business comes to me and says hey, I want you to be 99% of the times accurate with the decision that you take. That means you're given only a 1% chance of you going wrong. These two are related. Alpha, 1 minus alpha. If this is a scenario, then the p-value is compared with 1%. And you all know that 1% is equal to 0.01. 5% is equal to 0.05, so on and so forth. Now let us discuss about the case study pertaining to hypothesis testing. Now let us understand this hypothesis testing using a few case studies. We will be frequently revisiting this table, so put this table aside, and we will also be frequently revisiting this flowchart, so this aside. And here is the case study that we have to solve. If you read this case study carefully, it says that a financial analyst at a financial institute wants to evaluate a recent credit card promotion. So the business problem here is as follows. The financial analyst at a financial institute, they have done some promotions, some advertisements, and they have chosen 450 people randomly, and half of them, that means 225 of them, have received the full interest rate waiver advertisement, and another 225 people have received standard Christmas advertisement. Which advertisement is better? Is full interest rate waiver better or not? That is a problem that they are trying to solve. So the underlying business problem is, which ad is better? The second step as part of hypothesis testing is get into the data. Don't speak from the business language perspective now. We have already defined the business problem. We need to get into the data and try to identify what is Y and what is X. Given this scenario, Y is purchases made, X is full interest rate waiver advertisement, and another advertisement is standard Christmas promotion advertisement. So you have two advertisements. Which advertisement contributed to more purchases? That is what we're trying to solve. As part of third step, we need to identify the data type of Y and data type of X. Purchases here is continuous. Since we can represent purchases in decimal format and it makes sense, it's continuous. Full interest rate waiver and standard Christmas promotion are two categories or discrete. These two are of discrete type, and you have two categories here. When you have Y variable which is continuous and if you have X which is discrete in two categories, what test are we going to perform? Look at this. If I have Y which is continuous and X is discrete in two categories, we go with two sample t-test. However, whenever Y is continuous and X is discrete, we always resort to this flowchart. Y is continuous and X is discrete. And we are trying to compare two populations or samples with each other. When you're trying to compare the purchases of full interest rate waiver and purchases made because of standard Christmas promotion, you're comparing two samples or two populations with each other. That is when the first test that you need to perform is called as normality test. And as part of this, as part of any test that you want to perform pertaining to hypothesis testing, you need to first compose null in alternate hypothesis. If data are normal, you need not take any action. That is fine. You can proceed with the next step. There is nothing, absolutely no action needs to be taken. But if data are not normal, alternate, you need to take an action. And what is the action that you have to take? You need to transform the data. Take log transformation, exponential transformation, so on and so forth. Hence, you take an action if data are not normal. You do not take an action and proceed further if data are normal. And how do we determine whether data follows normal distribution or not? Using normal QQ plot or quantile plot. Let me open this specific case study called marketing strategy in Minitab, and let me try to explain. For now, I'm going to explain on Minitab, and in the next tutorial we will also solve it using R code. So here is that Minitab file. We have the purchases made by customers who have received full interest rate waiver advertisement, and we have purchases made by customers who have received standard promotion. So we need to perform normality test first. Now let us also write it down here. Yeah, the business problem. Business problem is full interest rate waiver more effective or not? Yeah, as part of this we are doing normality test, and as part of this null hypothesis says data are normal, alternate hypothesis says data are not normal. Now how do we perform this test, right? Even before we perform this test, we know for a fact that management wants us to be 95% confident with the decision that we take. So this 1 minus alpha is nothing but 95%. What does that mean? There is a 5% chance that you might go wrong, which is given a notation called alpha. And always the probability value is compared with alpha. And when you say that data are normal, if p-value is greater than alpha, that means if p-value is greater than 0.05, right, there is a slang called p-high null fly. Null fly, you fly, null fly means you're going to accept null hypothesis, right? I'll not be using statistical term, I'll be using the business term only. So you accept null hypothesis. Let me also try and reduce the size a little. Just give me a moment. All right. Now I think it makes sense. Okay. So p-high null fly. So I'll go back here. Here is a 2 sample t-test. I will go to stat, basic statistics. Oh, my bad. Here you have normality test, right? I select normality test and I select full interest rate waiver. I click on OK. By looking at this normal QQ plot, it is extremely clear that data follows normal distribution because all of these data points fall along this line. However, if you look at the p-value, it is 0.362. So the p-value here is 0.362, which is greater than 0.05. What does it imply? P-high null fly, right? Which implies accept null hypothesis. So the p-value is high, which implies null fly, which is a slang, which implies you accept null hypothesis. And what does a null hypothesis say here? Data are normal. Okay. However, you have done this only for full interest rate waiver. If you click on this, you'll go back to the worksheet. We also need to test whether the purchases made because of standard promotion follow normal distribution or not. So I once again go to Stat, Basic Statistics, Normality Test. This time I'm going to select standard promotion and click on OK. By looking at the data, once again it is extremely clear that data follows normal distribution because all of these data points fall along the line. Also, if you look into the p-value, Anderson-Darling test p-value, he was a person who has come up with this test. Yeah. So the p-value here is 0.103. This p-value is greater than 0.05, which implies p-high null fly, which implies we are going to accept null hypothesis. This is for your full interest rate waiver, and this is for your standard Christmas promotion. All right. If you look at this flow chart, it is very clear that if data are normal, then you proceed with variance test. If data are not normal, you would have done Mann-Whitney test, some other test. This is called as non-parametric test. Keep that aside for now. Since data are normal, we need to perform variance test.